Welcome back to Pre-Calculus, Unit 7. We are here in Lesson 10, and we are shifting our focus from the sum and difference identities to the half angle and later on the double angle identities. So this is another set of formulas that allows us to analyze specific angles even if they are not on the unit circle. So we're going to start off with three formulas. These are all half angle identities, and they are equations that we can use whenever the argument of the function is divisible by 2. So if we have the sign, anything that can be written as some number or some expression divided by 2, then we can use this identity for either the sine function, the cosine function, or the tangent function. So how does this help us? We can use the half angle identities to find the exact trig function values for angles that are a half of a unit circle angle, even if they themselves are not on the unit circle. So a good example would be 22.5 degrees. That's not on the unit circle, but it's half of 45, which is on the unit circle. So steps for doing this: you're going to start by rewriting the argument as half of a unit circle angle. So if you multiply by 2 over 2, then you'll have that form where you have some value of u in the numerator and 2 in the denominator. Then you would substitute into the correct identity, use the unit circle to find the exact function values, and simplify. And if you look at those three equations again, you'll notice that the sine and cosine identities have a plus or minus in front of the square root. So the signs are going to depend on which quadrant we're in. If it's in quadrant 1, then everything is positive. If it's in quadrant 2, then the x values, aka the cosine values, will be negative. So you do have to pay attention to which quadrant we're looking at. But let's dive right in with some examples. The first one we're being asked to find is the sine of 15 degrees. Now 15 degrees is not anywhere to be found on the unit circle. However, we can rewrite this so that it has a denominator of 2. To do that, I'm just going to multiply top and bottom by 2 over 2. So this is the same as the sine of 15 times 2, which is 30 over 2. So 15 is equivalent to 30 divided by 2. We're kind of unsimplifying, so to speak. But now this matches the form of this first half angle formula, sine of u over 2, where u in this instance is the number 30. So 30 over 2 is my u over 2. So if I go into my half angle formula here, sine of u over 2 is equal to plus or minus the square root of 1 minus the cosine of u divided by 2. So again, in our problem, the u value, the angle that is being cut in half, is 30 degrees. So this is equal to plus or minus the square root of 1 minus the cosine of 30 over 2. Now you'll notice that whereas sine of 15 was not on the unit circle, so we couldn't figure out exactly what that was equal to, 30 degrees is on the unit circle. So when I see cosine of 30 degrees, well, that's the x-coordinate of the 30 degrees, and that is root 3 over 2. So this becomes plus or minus the square root of 1 minus cosine of 30. Well, cosine of 30 is root 3 over 2 divided by 2. So from here, we have some tidying up to do of our fractions. First thing here is in the numerator, I've got this 1 minus root 3 over 2. I need a common denominator there if I want to do any subtraction. So I'm going to rewrite 1 as 2 over 2. And that allows me to combine this numerator into 2 minus root 3 all over the common denominator of 2. And this is still all over 2 from the bottom of the fraction. And it's all still under the square root sign. Now, I've got a fraction on top and the number 2 underneath, so it is time to keep, change, and flip. So I have this whole numerator here that I'm going to keep. 2 minus root 3 over 2, that all stays. But then I change to multiplication, and this denominator of 2, you could think of it as 2 over 1. I will flip that, and this becomes multiplication by a half. So dividing by 2 is the same as multiplying by a half. And again, this is all still under the square root sign. And now if I multiply across, the numerator is being multiplied by 1, so nothing changes there. It's still 2 minus root 3. But now on the denominator, 2 times 2 is 4. And that's all still under the radical. Now this numerator, there's nothing really that we can simplify there. The square root of 2 is not a whole number. The square root of a square root is definitely not a whole number. So that numerator, plus or minus the square root of 2 minus the square root of 3, there's nothing we can do with that. It's kind of messy, but that is as simplified as it gets. However, this denominator, we can take the square root of 4. The square root of 4 is a whole number 2. So that is my simplified answer. The sine of 15 degrees is exactly equal to plus or minus root 2 minus root 3 all over 2. Now, remember that I said we needed to think about what quadrant we were in to decide whether we were using the positive root or the negative root. So 15 degrees, this original angle that we are given in the problem, is half of 30. It's going to be somewhere in here where it's definitely in quadrant 1. So whatever these x and y values are, they are both positive. So this is going to be specifically the positive square root. So square root of quantity 2 minus root 3, all divided by 2, is your final answer. Let's look at another one. Here we have cosine of 75 degrees. 75 is not on the unit circle. However, it is half of an angle that is on the unit circle. So if I multiply this by 2 over 2, 75 times 2 is 150. So this is the same thing as asking for the cosine of 150 divided by 2. 75 is half of 150. We can use the half angle identity for cosine. So cosine of an angle divided by 2 is equal to plus or minus 1 plus cosine of u over 2. So in my instance, if I copy this down, cosine of u over 2 is equal to plus or minus the square root of 1 plus cosine u divided by 2. In my instance, the u, the numerator of this half angle, is the number 150. So this will be plus or minus the square root of 1 plus the cosine of 150 degrees specifically, all over 2. So 150 degrees, that is on the unit circle. It is right here. And the cosine, or the x-coordinate of it, is negative root 3 over 2. So cosine of 150 is equivalent to negative root 3 over 2. So this becomes plus or minus the square root of 1 plus negative root 3 over 2. and then that is still all over 2. And from here, we have some simplifying to do. So the first thing that you would take care of is your addition and subtraction, getting common denominators. I've got here a denominator of 2, so I'm going to get a common denominator with the 1. 1 is the same as 2 over 2. And then we can combine some like terms here in this numerator. So 2 plus negative root 3 is just 2 minus root 3. All over this common denominator, they're both over 2. And then all over 2 again from this denominator of the fraction. And this is still all underneath the square root sign. So now I've got a fraction on top and the number 2 underneath. So again, I would keep change and flip. So this is 2 minus root 3 over 2. We keep that whole part. Then change to multiplication and flip this denominator. Instead of dividing by 2, I'm going to multiply by 1/2. Again, all still under the square root sign. And then if I multiply across, multiplying by 1 doesn't change anything. So the numerator is still 2 minus root 3. And in the denominator, 2 times 2 becomes 4. So this is the square root that we have so far, plus or minus root of 2 minus root 3 all over 4. The numerator, we can't take the square root of the 2 or the square root of the root 3, so we're just stuck with this double square root of quantity 2 minus root 3. But we can at least simplify the denominator. Square root of 4 is the same thing as the whole number 2. So that is your simplified answer. Now we just need to decide what quadrant we're in. 75 degrees is more than 60, but it is still less than 90. So the 75-degree angle would be somewhere up in here. So the x and the y coordinates would both be positive. So again, in this instance, because we're in quadrant 1, the x-coordinate or the cosine value is positive, we will choose the positive root. Now let's look at an example that involves tangent. So here we have the tangent of 112.5 degrees. 112.5 is definitely not on the unit circle. But if I multiply that argument by 2 over 2, 112.5 divided by 2, or multiplied by 2 rather, is 225. So this is the same as the tangent of 225 over 2. So because this 112.5 can be written as half of 225, we can use the half angle identity, this time for tangent. So tangent of u over 2 is equal to 1 minus the cosine of u divided by the sine of u. And in our instance, the u, the angle that this is half of, is 225. So tangent of 225 over 2 is going to be 1 minus the cosine of 225 divided by the sine of 225. So let's find 225 on the unit circle. It is right there. And then let's get to work. So 1 minus the cosine of 225. Cosine is the x-coordinate, negative root 2 over 2. So this becomes 1 minus negative root 2 over 2. And that's all divided by the sine of 225. The sine is the y-coordinate, which happens to be the same number, negative root 2 over 2. from here, what we need to do is clean up and simplify all of these fractions. So subtracting a negative is the same as addition. I can make that change pretty easily. And we want to take care of our addition and subtraction before we keep, change, flip anything. So I have here 1 plus root 2 over 2. I need common denominators there. So I need that denominator of 2. I'm going to replace this 1 with a 2 over 2. And now I can combine those, 2 plus square root of 2, all over that common denominator. They were both over here, which is 2. So those are combined. And then it is all over this denominator here, negative root 2 over 2. So we've got a fraction on top, a fraction on bottom. Time to keep, change, and flip. So we're going to keep the 2 plus root 2 over whole number 2. Change to multiplication, and we're going to flip this denominator so that the negative whole number goes on top and the radical goes on the bottom. Now, I do see a whole number 2 in the numerator and a whole number 2 in the denominator. So we can cancel those out. However, I'm still left with a negative sign, or a negative 1. So both the whole number 2 and the square root of 2 in that numerator become negative. And I'm left here with the radical 2 in the denominator. And now we are not quite finished because we do still need to rationalize. I'm going to multiply top and bottom by this radical 2. And here, don't forget to distribute. This gets multiplied to the whole number, and it gets multiplied to the square root. So negative whole number 2 times the root 2. And then this is minus root 2 times root 2, which is 4, or root 4. So we'll put that down as root 4. And actually, I'm just going to simplify that straight away. Square root of 4 is the whole number 2. And then in the denominator, same thing. We don't have to worry about distributing here. Just do root 2 times root 2, which becomes root 4. And again, I'm going to simplify that straight away. Root 4 is 2. Now, one last step is that everything here is divisible by 2. So we can do 2 divided by 2 and cancel that out, and 2 divided by 2. Everything there is divisible by 2, so if we divide that out, we are left with the negative square root of 2 minus 1. And that is our final simplified answer. Tangent of 112.5 is equal to negative root 2 minus 1. So the difficulty here is not so much in using the identities, but in being really careful how you are simplifying your fractions. So remember that when you go to add fractions, which we did up here, we were adding fractions, we needed to get a common denominator, and then we had a fraction on top and a fraction on bottom. So we did the keep, change, flip, and cancel. And then we ended up with a square root in the denominator. So we had to rationalize and multiply both top and bottom by that square root. And then finally everything simplified down. So we've done one example here for sine, one example for cosine, and one example for tangent. We have 2 more problems here, and these are on your own problems. So if you're feeling confident, you can pause the video and then skip ahead to see the final answer. If you are still not super sure about these, go ahead and follow along. I will do one more example here with us. So we have sine of 165. Not on the unit circle, but if I double it, 165 times 2 is 330. So 165 is the same as 330 divided by 2. So this is half of an angle that is on the unit circle. This is a sine function, so we will be using the half angle formula for sine. Sine of any function, any expression, any u value divided by 2 is equal to plus or minus the square root of 1 minus the cosine of u divided by 2. And in our instance, u, the angle that we are taking half of, is 330. So the sine of 330 over 2 will be 1 minus the cosine of 330. So this gives us 1 plus or minus the square root, rather, of 1 minus the cosine of 330, and then that's going to get divided by 2. So finding 330 on the unit circle is right here, and the cosine is the x-coordinate. That is going to be a root 3 over 2. So this becomes plus or minus the square root of 1 minus root 3 over 2. And then that's all over 2 in the equation. So now to simplify the fractions, I should take care of the subtraction first. And to do that, I need a common denominator. So I'm going to replace that 1 with a 2 over 2. And then I can combine these two terms that are being subtracted. 2 minus root 3 all gets put in one single fraction over that common denominator of 2. And now this is all still under the square root sign, and it's all still over a 2 from the formula. So here we've got a big old fraction on top and the number 2 in the denominator. So dividing that big old fraction by 2 would be the same as multiplying it by 1/2. So I'm going to keep that 2 minus root 3 over 2. But now instead of dividing it by this 2, I'm going to rewrite that as multiplication by 1/2. And this is all still under the radical. And if I do that, multiplying by 1 doesn't change the 2 minus root 3 at all. But my denominator is 2 times 2. That becomes 4. So this is all still under the square root. And the root of 2 minus root 3, there's no way to simplify that. So it's still just going to be plus or minus square root of quantity 2 minus root 3. But at least we can take the square root of 4 and turn that into a whole number 2 that is no longer under the radical sign. So that's my simplified answer. And then I need to go back to the beginning and see where is my angle, what quadrant is it in, should I be choosing a positive or a negative root here. So 165 is somewhere around about in here. It's between 150 and 180. Exact location doesn't really matter. What's important to us is that this is going to have a negative x value and a positive y value. So this point here on the circle, it is to the left, so x is negative, but it is up, so y is positive. So if we are looking for the sign, that's the y coordinate, so it is still going to be a positive number. So my final answer here would be the positive root of quantity 2 minus root 3 over whole number 2. So that is the sine of 165 degrees. We have one more U-try problem. This is the cosine of 67.5. So go ahead and pause the video and try this one all on your own. And here we have our answer for this problem. So we started off with the square root of 1 plus cosine of 135 divided by 2. The cosine of 135 is the x-coordinate negative root 2 over 2. And from there, we combined fractions, did a keep change flip, took the square root of 4, and ended up with this answer, plus or minus the square root of quantity 2 minus root 2 all over 2. Now the last thing we need to decide is whether we're using the positive or the negative root here. And for that you want to go back to the very beginning. What quadrant is 67.5 in? Well, that's going to be just past 60 degrees, certainly not to 90 yet. So somewhere about there on the unit circle. Important thing being that both the x and the y values are positive, so we are going to choose specifically the positive answer here. And I think I lied earlier because we do have one more U-try problem. This is a tangent problem. 105, if you double that, multiply it by 2 over 2, would be 210. So this could be rewritten as the tangent of 210 cut in half. So go ahead and plug that into the tangent half angle identity right here and simplify it out. See if you can get the same answer as me. And here is your final answer for this one. We ended up with negative 2 minus root 3. So up here in the tangent identity, we did 1 minus the cosine of u. Cosine of 210 was negative root 3 over 2. Divided by sine of u, the sine of 210, or the x-coordinate, is negative 1/2. So the first step would be to combine these fractions here in the numerator. So I replace the 1 with a 2 over 2. Two negatives make a positive, and so you end up with 2 plus root 3 over that common denominator of 2. And then you keep change and flip. So you would keep that numerator, flip the negative 1/2 to negative 2 over 1, and cancel and simplify. So those are 6 examples of how to find exact values using half angle formulas. And these are useful, again, to get exact values out of the unit circle, even for angles like 105 degrees that are not explicitly on the circle.